Welcome to part 3 of the video where we are going over using open source photometry analysis program GuPPY for analyzing data collected on a Plexon multi-wavelength fiber photometry system. First, we're going to go over how to correctly format the CSV files for use in GuPPY. So here we are looking at data for fluorescence. On the left is a Plexon exported CSV file, and on the right are GuPPY formatted CSV files. For GuPPY, you must have a separate file for each wavelength, each fiber that you've collected. So there's only one set of data in each file. Additionally, the headers must be exact. They must say timestamps with an S, data, and sampling _ rate. All lowercase, no spaces. And this is compared to a Plexon exported file shown here on the right. So there are multiple columns here that we actually will not need, such as the first column, frame rate. The second column is the timestamps, and then the following column are all data. They will all have a number indicating the LED, so 465, 410, or 560 nanometer LEDs. It will also have an _ F1, F2, F3, F4 to indicate which fiber those data were collected from. So here I have shown the raw F or raw fluorescence values. You can also export an F0, which is a moving baseline, and the R data, which are a baseline corrected data. So because both GuPPY and pMAT do all the calculations, including a baseline correction, we want to start with the raw fluorescent values in our CSV files. So simply to convert a Plexon exported CSV file to a GuPPY format CSV file, you need to just delete the columns that are not needed in each file, and then save again separate files for each data type. So raw 465 will be in one file, raw 410 will be in another file. If you have a 560 nanometer LED related signal, then that would also be in another file. Data file names don't need to have a specific format, but just keep in mind the data file names cannot be the same as the store names. And I will get to store names later as we run these data through the program. So my advice is to name the data files uniquely and also very specifically. And again, I cannot stress enough, these headers must be exactly as shown here and exactly as shown in the GuPPY sample CSV files that are online at their GitHub page. Next, and a little bit more involved, is correctly formatting the behavioral data or TTL event data. So on the right, the GuPPY format CSV file looks very simple. It is a single column of timestamps of each occurrence of the TTL event. This is the onset timestamp if you also were looking at the pMAT formatted data, which needed both onset and offset. GuPPY just needs the onset. So a single timestamp for each occurrence of the event, and each event will have a different file. The header again must be exactly timestamps with an S. The Plexon exported CSV file exports the frame number in column A, timestamp in column B, and then each event is in its individual column. And for each timestamp, there's either a 0, which indicates the TTL or event was not detected, or a 1, indicating the TTL event was detected. So as you can see here, there are multiple consecutive timestamps that have a corresponding 1, indicating that that event was occurring. So in this example, and in a lot of cases, the TTL event is 0.1 seconds long, which at 30 Hertz of data collection is 4 data points. However, even in this example, you can see that there are more than 4 consecutive timestamps where an event was detected. So this is because the TTL pulse start and stop does not completely and exactly align with the frame collection. And so this leads to a little bit of TTL length jitter in that it's detected in more frames than would be calculated by the length of 0.1 second, even though the TTL is only 0.1 second. And the only reason I'm stressing this is because as I show you how to find these event occurrences in the Plexon file, you will not be able to simply select every 4th point because of this TTL length jitter. And because of this, Plexon has made a cheat sheet file, which we use to format the pMAT data, and I'll show you how to use that for formatting GuPPY data as well. So let me show you how to find these events manually, and then I will show you our cheat sheet. So here I have open the raw event data exported directly from Plexon's multi-wavelength fiber photometry system. Again, we have a column for frames, timestamps, and then for our event occurrences. It's a logical 1 if it's occurring, 0 if it's not. So the first thing we have to do is sort these data because we need to find where the air puff is occurring, where the value is 1. And we can do this by using the sort function in Excel. So we're going to tell it to sort by air puff column. So it's going to say, look at the value in the air puff column. And then we're going to tell it to sort it based on largest to smallest. So it's going to find where it is 1 and then put that at the top, find where next is 1, put that at the top, etc., etc. And as we see, here are the results, and here we can see the consecutive timestamps for each event. So then off to the side, if I can spell, off to the side you can create a timestamps table, which you will then copy paste into a new CSV file. So very simply, you would just do copy, paste, each time there is a new consecutive timestamp group. So as you can see, this could be very error prone because you are going through it manually. And if you have a lot of events, a lot of files, this could take a while. So let me show you how to use our cheat sheet. So this Plexon cheat sheet has 3 different sheets on it. The first is just the rules and how do you use this. The second is the only one you will paste any data onto. And very simply, you can paste up to 6 events, and you will take the data straight from the Plexon exported CSV file. And then the reformatted sheet will show you the event, the onset, and the offset timestamps. This is specifically what you will need for pMAT, but we can take the onset timestamps and use them for GuPPY. So let me show you exactly how this works. I'm going to open the original session data, which I did not sort. I'm going to use a keyboard shortcut holding Control-Shift. I'm going to hit the right arrow key to select consecutive columns that are full, and then still holding Control-Shift, hit the down key. So this will select all columns and all rows that are consecutively filled with data. We're going to copy that, just Control-C. And then because I copied the headers, I'm going to paste in A2, and then it's going to paste the data. It's going to automatically do all of the sorting to pull out those air puff events and find the onset and offset timestamps. So this will take a minute because you have thousands and thousands of data points. So paste your data, get up, go get a snack, and come back, it'll be done. And due to video magic, I have fast forwarded to when it was done. And under the reformatted sheet, you can now see that the event air puff, we have both an onset and offset timestamp. So again, because we only need the onset timestamp, we can open a new workbook and copy just that column. Now, importantly, when we're pasting these values into a new workbook, you want to do right-click, paste values. So you need to paste values because the cheat sheet uses formulas to find the TTL timestamps. And so if you try to paste those formulas into the new workbook, you are going to get gibberish. And then don't forget to put the header. So then we can do file save as, and the reason I'm doing a save as is because we need to make sure it's a CSV, delineated file. One other thing I want to point out is in my GuPPY formatted data folder, I have two separate folders. One says sample data and one has session 11 data, which is the data I just formatted. The reason I did two separate folders is because of how GuPPY uses folder organization to do group analyses, which you will see a little bit more of when we actually run these data through GuPPY.